Until this point, you have learned the basic rules. Power rule, derivative of sine, derivative of cosine. More basic rules, though they came later. Derivative of secant, and cosecant, and cotangent, and tangent. Derivative of constant multiples, in general what to do. Sums and differences, in general what to do. E to the x, ooh, he's a fun one, hopefully. However, even though we just also learned the product rule and quotient rule and saw that sometimes things are tricky, but sometimes they're not as tricky as they have to be if you remember the green trick. Ooh, remember that one? Factoring out what's in common. If we did not keep going to this rule, a lot of that work would be in vain, at least as far as AP multiple choice questions. Because AP multiple choice, derivatives in general, for the rest of the point, always, I think I said 90%. I kind of just grabbed that number out of the air, but I didn't want to say 100% because it's not true, but it is stinking high. My guess would be 90% of the time needs the chain rule. There are different ways of thinking about the chain rule. My original illustration for the chain rule, like way back when I first started teaching calculus, had to do with bunnies. Because bunnies multiply, if you know anything about bunnies. They multiply. Doc Ranieri was subbing on campus yesterday, day before, maybe she's still subbing. And she brought up something about her tortoise and her bunny, her rabbit at home. And then I was like, wait, do you have multiple rabbits? She's like, no, I just have one. And then someone's like, you better keep it that way. As soon as you have multiple bunnies of multiple genders, they start to multiply very fast. Out of, I wouldn't say necessarily all Animalia, but they're definitely one of the quickest reproducers because it doesn't take a lot of time for a bunny to reach maturity in order to be able to reproduce. Anyway, there's this whole thing. Fibonacci sequence, 1135, that was built off of bunnies, ironically enough. Anyway, bunnies are pretty mathematical if you think about it, but the first way I talked about the chain rule was bunnies, and you'll see why as we keep on going. Bunnies multiply, that's one way of thinking about it. If you make a chain rule mistake on the backboard, a bunny dies. I'm going to go ahead and show you guys. You only will understand half the rule right now because one of them is a derivative. The other one is an integral. We haven't done integrals yet. That's the area under the curve. But let me show you how a bunny dies. A bunny dies if you were to say that that is right. Okay? A bunny dies if you were to say that was right, because this is wrong. But we have no rule right now. We have no rule as far as sine, well, it's not sin times 6x, right? That's not how we read that. We know better than that. Even though the parentheses aren't written, what is this, guys? Sine of 6x. How many fingers do I have? I have sine of x on the outside, and I have 6x on the inside. Now, it starts to get a little confusing if we were to write it that way, even though this is going to be part of the notation. F of x is equal to sine of x. G of x is equal to 6x. This is technically right, because then f of x would be this guy. You would plug the g into f's x spot. But some people don't like that notation, so another alternate way of thinking about it, you could also think about f as being f of u, which is sine of u, and then u would equal 6x. Do you guys see why some people like that a little bit better? Because it's not quite as confusing having x's all over the place, and you're like, oh, u needs to get plugged in. Got it. So you could also say that this is f of u. We might see some other notations today. This notation gets a little tricky once you have an f of g of h. This one would be easy. Of h, we could have something inside the 6x and just keep going. Of h, of j, I wouldn't use I. Why wouldn't I use I? Imaginary numbers, yeah, I wouldn't use I, but j or k or l. We could just keep going and have inside, 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 all sorts of matryoshkas. However, this notation gets a little bit harder because this one would need to be u of, right now technically, even though I don't write it, technically this is u of x. It looks kind of confusing, but it's technically u of x. If I needed to add something else, I might need to make this u of v and then have v of x, or u of v, then v of w, then w of x. This one only has x in the very front. So this notation can get a little funny, a little weird, all that's kind of nice in the beginning. But here's the main idea. All of these examples that you guys should have already written down, can I solve them with basic rules as far as the first derivative? Yeah. Even the second, third, and fourth derivatives. Yeah, I can solve all of these with basic rules. Basically just x. Just x. Just x. Just x is being times 3. Just x is inside sign. Just x is being squared. Just x is being added of just x. What's different over here? Raised to the fifth. Or a g of x being raised to the fifth. A u inside sign, or a g of x inside sign. I have a u inside or under the root, or a g of x under the square root. I have a u inside the tangent. Now, can I solve that guy basically? Yeah, just with basic rules. That's easy. That's 1. But I have a u or a g of x inside tangent. These all need the chain rule. Well, one. Only one can be solved with basic rules. Can you guys figure out which one? Only one. Nope. First one. But how? Not as it's written. You gotta go? Let's go. 5 times. Well, 4 times. No. Who wants to? Nobody. Ain't nobody want to do that or have time for that, right? Okay. Which is why, if all these other ones need the chain rule, I'm not going to raise that to the 5th power. I'm going to learn the chain rule and use the chain rule for that. And maybe, just maybe, do some of you remember that problem yesterday, the one that you got stuck on? Did just a couple of you wonder if you could have taken the derivative just like this without rewriting it like that? Now, I went that way because you only had basic rules, so you had to yesterday solve it like that. But maybe, just maybe, 1 or 2 or 5 or 10, it didn't sound like all of you, but maybe you pondered, how do I take the derivative of this guy without? We'll learn today. Have you figured out yet when we need chain rule? When we have what types of functions? What are they called? You can say matryoshka, but that's not the technical mathematical term. What's the mathematical? Well, the rule is called the chain rule. But what types of functions? From pre-cal, we talked about these types. What? Yeah, composite functions, or in this wording, compositions of functions, yeah? Whenever we have compositions of functions. And it doesn't just have to be an f of g. It can be an f of a g, of an h, of a j. But we're going to start with just f's of g's. So I want you guys, even though we've already done it, I want you to take those same functions, and you could even just go up. You could even go up above if you want. And in the table, you could just add a 3rd column and make that 3rd column something like decomposition, decompose. Remember decomposing bodies last year? Break it down into its elemental pieces. It was in chapter 1? Yeah, chapter 1. Decompose the functions. So I'll show you 2 different ways of writing it. You could either, on this top one, you could either rewrite it as f of x equals x to the 5th, and g of x is equal to 3x plus 2. You could use the f and g notation like I did up here. With f and g, g goes inside of f. Or you could also use the f of u notation, u to the 5th, where u of x is equal to 3x plus 2. I want you guys to ponder both of those, pick a way, and use it for the other ones to go ahead and decompose the functions. Talking about the different pieces, the different elements. one inside the other. P.S. G of x, or u, is always the innermost. Unless we have an innermost inside an innermost. Ah, that's where this comes in. But all of these just have two. Either f and g or f and u. Go ahead and get them down. How would you break it up? Choose a way, and then break them down. I'm going to slowly come behind you. I'm going to show all of them. Just, it depends on your brain as to which one you'll like more. I'm going slow. Get ahead of me if you haven't yet. Whew, I'm sorry it's getting cold. Who's done already? Uh-oh. You guys letting me beat you? Are we getting the idea down of an outer function and an inner function? Okay. This last one's a little tricky because both pieces do not need the chain rule. And we know the sum or difference rule that we would take the derivatives piece by piece whenever we have a sum. So I'm just looking at the second part because it's the only part that needs the chain rule. It's the only part that's a composition. If you try to write the entire thing as a composition, it's just going to get messy and confusing, and actually harder. So just because we know the sum and difference rule, we're only looking at the second part. Question. How many of you guys think, I mean, it might change, but think right now that the blue way makes more sense to you? Okay, how many of you guys think the green way makes more sense to you? Okay. We'll keep playing with it. You might change your mind, that's totally fine. But do you at least get the idea of breaking it? Okay, and that each of these only technically have, I'm going to take this bigger one out, only have two. Just an outer F and just an inner G. Ooh, squeaked, sorry. Okay, so what do we do with these? What do we do with these? If we think about it in terms of U, I can kind of show you a little bit easier where the rule comes from. Have to be stuck to the U notation. So only like 2 of you guys U notation, at least as right now. I'm going to show you where the rule comes from with U notation. And then we'll see if it makes sense. If we're trying to derive, does it make sense, first derivative, that we're just trying to get to a dy dx? Does that make sense, guys? Okay. We're trying to get to a dy dx. And to get to a dy dx, if we have an f of u, and if we have a u of x, okay, whenever you see a u in calculus, it almost always is denoting the inside of a composition of functions. So you're given basically an f of u, you've broken it down into your pieces like the page before. We could take the derivative of, nope, in terms of the variable that's inside. So this is where it's going to get a little weird. We could take the derivative with respect to u of the guy who has thinking that we would get all the way to the end. But the problem is, if we were to take the derivative of the guy in terms of u, just the first piece, and we only take his derivative, we would only end up with dy du. Is that the same thing as dy dx? If we took the derivative of this guy, the outer guy, if we only looked at him and only took his derivative, we would have dy du. Because we would be taking the derivative with respect to that variable, the u. And we wouldn't get dy dx. But here's the cool part. We can take d dx of the u and check out what we get. Why does that look good? The du's cancel. And we've found the dy dx. This is showing you why. I called it the bunny rule once upon a time. Bunnies multiply. We can't just look at the outer guy. We can't stay looking just here. We have to look inside also. But we don't just look inside. We have to multiply. Like bunnies, we have to multiply by the inner's derivative. We could do a lot of life lessons right now, as far as we can't just look at the outer, but we have to look at the inner. God looks at the heart. Anyway, but for right now, chain rule. We have an outer function, we have an inner function, right? If we just look at the outer guy and just take his derivative, hey, that's what this problem is. Just looking at the outer guy. Just taking his derivative. But who did we never consider? We never considered the 6x. Let me simplify the notation for this really quickly and show you what you're really going to be doing. When you take the derivative of this guy, another way of writing the dy du could be f prime of u times u prime of x. Another way of writing that, if I was to actually do this in like the blue and green from the page before to kind of tie it all together, let me move this down just a little bit. That was just showing you why it's necessary, why it's important. If I was doing blue, technically it'd be f prime, take the derivative of the outer shell, totally ignoring it. Like the inner shell's in there, but I'm not deriving him. It'd be f prime of g of x times g prime of x. That's the blue notation. The green notation would be f prime of u times u prime times u prime. Guess how much you're going to hear u prime this year? Oh. Hopefully not a lot, because that means you're not killing bunnies, but if you're killing bunnies, you're going to hear it a lot, because what is the proper way of deriving this guy? I would need f prime of u, if I was to use the green notation. I would need f prime of u times u prime. F prime is who's on the outside? Sine. Take its derivative. Cosine. Oh. Keep the u. But don't stop there. You got to peel off the side. Say, okay, who's inside? 6x. And who's 6x's derivative? It's as easy as that. Bunnies multiply. Don't kill one. Chain rule. Think about just the outside function. Take his derivative, but then who's inside? Multiply his derivative next. Yeah? So, chain rule. You can think about it. Links to a chain. For the derivative of a composite function, you have to link together with multiplication all of the inner function's derivatives, but in sequential order, peeling off one layer at a time. So if you have an f of g of h, what's that going to look like? F prime of g of h, right? F prime of g of h times, who would be next? G prime of h times h prime. You guys just figured out the rule for a really complicated composite function. F prime of g of h times g prime of h times, you could do it if there was 4 or 5 or 10 or 12. You could do it just by peeling off one at a time. Let's get the rule down, yeah? Let's not do the rule yet. Let's practice first. So this guy, didn't we all talk about how we really didn't want to multiply him out to the 5th power? Okay. He's an f of g. He's an f of u. We're going to do this guy, I think, 2 or 3 different ways to let you guys see if you still want to stick with the f and g or if you want to change to the f and u. And technically, there's one last way. So the first way, f of u. I'm going to do the f of u form first, okay? The f of u form could be the following. I could rewrite this guy to be f of u equals u to the 5th. U is equal to 3x plus 2. My derivative for dy dx would equal f prime of u times u prime. U prime. If that was my phone, I really apologize. I might not have turned off the sound. F prime of u times u prime. So f of u. Guys, look at the guy with u's. What's his derivative if you just derive him as he is in terms of u? 5 u to the 4th times. What's u prime? 3. But wait a minute. I can't stop there. I need it in terms of x. So what's your final analysis? Or your final step, I should say, in simplification? dy dx is equal to 5. Who's u? Can you imagine if you actually had multiplied this out to the 5th power and you'd had this huge 5th degree polynomial, taken the derivative step by step, how would you have made it match to this nice, pretty, factored little quartic polynomial? Oh, right? Synthetic division, long division, rational root theorem test from last year. Just throwing together words that kind of go together. Anyway, you would have had to factor it to make it match, or you would have had to multiply out every single multiple choice answer until you made it match. Ah! Chain rule, chain rule, chain rule. It's glorious. Look at him. Derivative of the outside, 5u to the 4th, times derivative of the inside. And then I had to bring it back in terms of x, and then finish. Nick? Yes. So we don't ever have to expand a polynomial again. Yeah. This is u notation. What's f and g notation? My people that liked the blue. It was most of you. Okay? You already wrote down f of x is equal to x to the 5th. G of x is equal to 3x plus 2. The derivative rule for dy dx would be f prime of g of x times g prime of x. Kind of like we were just saying with the matryoshkas. Just looking at the outer guy. F prime, who's inside? G. F prime of G times G prime of, just of X. Just of X. We're done. There's no H. Okay? How would this work? This is where it gets hard. What's F prime? First of all, what's F prime? But I'm not going to put an X because who needs to go inside? See it? So it would be 5, who to the 4th? G to the 4th. Oh, it starts to get a little confusing. Not impossible, just starts to get a little confusing. Times G prime, 3. Who's G? 3x plus 2. Do you end up with the same answer? Yeah. Do you get there a little bit of a different way? Yeah. But some people shortcut this process eventually. Once they get a really good handle on it, once they really master it, some people get to where they can just say, oh, hey, 5, but 3x plus 2 to the 4th times 3. Ha! Some people can get here very quickly because they realize, well, let's do it in words before I answer the question, then I'll come back to the question. There's another way of thinking about it that might simplify the process a little bit For some of you, the only problem is if you don't have the rule mastered, once you have an f of g of h, or once the composite functions get tricky, your brain loses track of the steps. Shortcuts are always dangerous because you're not always thinking through the legality of everything that you're doing. For right now, it ended in the same place as the other one. But let's try the words. Because I'm going to have you guys put a forever card and put down 3 different variations of the rule. Okay? In words, you can think derivative. We'll say derivative. Okay? Derivative of the outer, keeping the inner unchanged. Derivative of the outer, of the inner unchanged, times derivative of the inner. Derivative of the outer, keeping the inner unchanged, times derivative of the inner. How does that work? I guess I have to choose a different color since we've already done blue and green. Derivative of the outer. Bring down the 5. The outer, something to the 5th. Oh, 5 something to the 4th. A video that you guys will watch right before we're done with everything. Let's review for the AP time. A guy's going to go through calculus in 20 minutes, and he's going to put a piece of Play-Doh and be blop to the 5th. What's the derivative of blop to the 5th? 5 blop to the 4th. What's the blop? 3x plus 2. Keep the inner unchanged. It simplifies the process of plugging back in the u, of plugging back in the g. Derivative of the outer. Blop to the 5th is 5 blop to the 4th. Oh, there he is. But there was a blop. Ah, blop prime. What's blop prime? 3. Dun, 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 dun. But this is so dangerous. Ah, so dangerous. So many bunnies die. So dangerous if you don't have an excellent handle on the rule. Michael, what was your question? As long as you never forget the poor little bunnies. As long as you never forget the bunnies. But isn't that awesome, though? That could be so fast. But we got to master the rule because it's going to get harder than that. Nick?
So what if inside there, like
3 tangent?
Like 3x squared plus 2x.
Oh, you would just do for here, parentheses, because it's going to be times that prime, so it's going to be parentheses. But it would be like 6x plus 2. And then you would just leave it like that, and that would be, if we did our huge, can't really explain it. If you expanded the huge polynomial with something inside, and then you factored it properly, you'd have a lot of these and this other extra guy. Does that make sense, kind of? Okay. Guys, let's get the rule down. Forever card number 13, I think, is the consensus. You might want to double check. Because number 12 would have been the trig rules. Is that the last thing we did? Okay. Let me give you guys a second. Right now, I've alluded to how it could get harder. But if you guys have noticed, I've also done a lot of mental math with the basic rules. Derivative of something to the 5th, 5 something to the 4th. Derivative of 3x plus 2. Oh, that's 3. We're making the basics go faster and faster and faster. But what do you have to be careful of as soon as you speed something up? Yeah, making mistakes. If you're trying to learn a new move in basketball, or I would assume it'd be similar in any sport, you go through the slowly first, and then you build up speed little bit by little bit. Same thing with an exercise. If you're trying to do a new exercise and avoid injury, you go through the movement very slowly until you get the hang of it, and then you increase your speed. Same thing in math. But you have to be careful because you're going to have to do the G prime and the H prime. So you have to get the hang of it. But yeah, it works. Just I wouldn't start there. You can, in the back of your mind, be thinking, how could I speed this up if I understand? Guys, I think you're going to understand when I start plugging in. Because we've already done this technically. Derivative of the outside, keeping the inside unchanged. Deriving the outer shell, the inner one completely untouched. But then I have to peel off that outer shell and take the derivative of that inside function. Technically, we could peel off the G, but all that's left when we peel off the G would just be X. And guess what X prime is? Where X's derivative is? Just 1. So whenever you get to peeling off and you just get a little baby X, his derivative is 1. It's poof, it's gone. 1 times anything is itself. That's one way to know when you're done peeling off. The other notation, F prime of U prime. Technically, this will probably be the easiest for those of you that tend to make mistakes on shortcuts. This will be the easiest form that can deal with complicated functions in a simpler way. Not a faster way, but a simpler way, where your brain will make fewer mistakes. So some of you might want to put a star by this being like, oh yeah, I make mistakes when I do shortcuts. You'll probably want to stick to the U notation. The other notation is what we saw as to why the rule has to be what it is, considering the outer in terms of U, and considering the inner in terms of X. This lets us break it down and remember why we have to go the U prime. We have to go this extra inside prime. And so in the words we can say dy dx, the derivative is equal to the derivative of the outer. I say keeping the inner unchanged. I could just say of, but I think a lot of you guys would get lost in that. Derivative of the outer, keeping the inner where it is. Derivative of the outer, keeping the inner where it is. Derivative of the outer, keeping the inner unchanged. You guys want to do some nasty surgery thing going on where you're deriving the outer and the inner all at the same time. You can't get to the inner until you peel off the outer. With the bunnies, it would be like you can't derive the inner until the inner's born. Don't go in there. Let's not even get political right now. But you shouldn't be doing that, right? You shouldn't be going in when the baby's still in the mama, right? So, derivative of the outer, keeping the inner unchanged. Keep that thing unchanged. No deriving until, okay, there we go. Now we can do derivative of the inner. The bunny idea does kind of help. As far as multiplying, always times U prime, always times G prime. And the whole, like, when the baby's inside, don't touch it. Where's my Matryoshka doll? When I'm deriving the outer, you can't even see the inner. Like in math, you're going to be able to see it. Like it's going to be written out. The G is going to be inside the F prime. The U is going to be inside the F prime. But we cannot derive until we finish deriving the outer. Times. Now we peel off. Now we take his derivative. It must be kept separate, or else you're going to make so many illegal mistakes. And the AP is going to be waiting for you, being like, ha, 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 here's the answer you think it is. What's at the very, very bottom? What if we have more functions? Here's our, what if we have, and I'm just going to write just one example, an f of g of h. Is that as bad as it can get? Not necessarily, but probably. It's one of the worst. It all depends on who's inside of there. Is there a product inside of there? Is there an e to the x inside of there? Is there a trig inside of there? I don't know. But we have there, there, there. We're trying to derive an f of a g of an h, like my Matryoshka 3. Guys, use what you've done here to fill in this rule for me. I said it once today already, and you guys said it with me a couple times. Who's the first guy that gets derived? F. What happens to all the guys? Remain unchanged. Stay the same. Okay. Once I've dealt with F, now what? Good. G prime. Who's still inside G? Leave him there. No abortions today. Yep, I did it. Keep going. Now what? I have to keep going. No, you don't. What would be the last layer? What's X prime? Forever card number 13. Are you masters? No. Is it starting? Maybe. Some synapses are firing. Maybe some things are connecting. We've already done this one so many times. We're not doing this one again. But, wait, it's the same as that one. Okay, well, get it on your notes. Get it on your notes. Unless you guys were copying down from up there. How would you properly not kill a bunny? Now, pause. I can mental math this all day, but I'm not going to because I'm trying to make you guys go slow. Okay? I'm going to show the notation that I think will be best for those of you that are most prone to making mistakes, which, to be honest, is all of you for right now. Okay? So I'm going to use the notation that I think is best for most of you, at least for right now, which is going to be U notation. Why? Because when you go to take the derivative with U notation, you take the derivative of this guy, which is cosine of U. You won't forget if you keep it with U's, times U prime, which is 6. But you cannot stop there because I still need to plug in for U. Who's U? So the final answer. And look what I did. I took the derivative of the outside, derivative of the inside. Dun, 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 dun. Ready? Set. Pick a notation for number 3. I'll do it both ways. And then I'll end with what I just did here, doing it in words. You can try the F and G. You can try the F and U. Be careful how you say that. For me. Anyway. Rise above, rise above. Okay. Top scholar's too long. Shh, pick away, go! So true. Some ways forced to be an adult, and some ways forced to not fully mature. It's deep. We're getting deep this morning. It's because I had my coffee. And we're playing with the chain rule. I do always have it on mission trips. Although usually on mission trips I'm humbled more than any other time. But it's okay. You get wise and humble. Oh man, we're getting good today. Pain is a gift. Hard but true. Then go back and reevaluate and try a different way. I would say it might be a little complicated, especially if you don't think to rewrite it. Some of you might have gotten stuck from the beginning if you didn't think to make it 1/2 power. Okay, I'm going to go ahead and split this up. What do you guys want me to do first? Blue? I'll do blue. I just did green. Okay, so f of x. Calculus, ain't nobody got time to rationalize. Leave that square root where he is. Did you not keep them unchanged? So then see if the U notation would have helped. Okay, then it's okay, it's okay. It's okay. What happened? dy dx is equal to 1/2 u to the negative 1/2. You have to get back in terms of x. You can't leave it with u's. Yeah, but to make it match. Remember how in the original, when we were first doing like basic with square roots, like if there was a square root to begin with, there should be a square root to end. That's almost always the simplifying. But if it was a multiple choice question, your eyes hopefully would glance to the answers and see like all these 1/2 powers and be like, forget that, I'm not going to simplify. Or see all the square roots and say, oh, I better go back to radicals. So how does this work as far as words? Blop to the 1/2. What's the derivative? 1/2 blop to the negative 1/2. Wait, so dy dx is equal to 1/2 blop to the negative 1/2 times blop prime. Dun, 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 dun. Does anybody need clarification as to the way they used and how it did not match up to what's up here? You don't have to tell me that you didn't get it right the first time, but is there anybody who got lost in the process and still doesn't know how based on what I did? So, let's just apply the U notation. Let's just apply the U notation to one basic rule, the power rule. Let's just apply the U notation to one basic rule, the power rule, and see if by talking through a few basic chain rule types of problems, we can speed up just a little bit on specific types. Not on all types, but on specific types. We're not going to make a forever card out of this, but this is an expansion of the power rule. What if you don't just have an x to the n? What if you have a u or a g of x to the n? What are you going to do every single time? This was, Michael, what you were seeing. I'm just going to bring down the n. I'm going to make it n minus 1. I'm going to say u prime. But some of you, and for right now I'm going to say the majority of you, will make mistakes if you speed up too fast. So what I'm going to do right now is I'm just going to say, hey, there's a u and he's squared. There's nothing harder than that. There's no h of x that's inside this, that's inside this. It's just a u being squared. And this u I can deal with. I could deal with him if he was on his own. If I met up with him in the dark of an alley somewhere or others, I can derive him. That's okay. Right? So all you need to do is say, who's u and who's u prime? What's the derivative of inside? Secant squared of x. Ooh, we're not so confident on our basic rules anymore. What would be the derivative if I was to rewrite this as u squared? dy dx. According to this power rule up here, how do I take the derivative of u squared? 2u times u prime. U prime, which is going to be 2 tangent of x plus 1 times secant squared of x. Could we rewrite it to make it prettier? Sure. Should you be able to make it match with that? Yes. Okay. You guys, do number 2. Maybe. Double check the legality of it. Some of you will be able to speed up. Just be careful. If you go too quick too soon, you might get it right for a few, and then, since the idea isn't solid, you might start falling apart. Not the 1/10. Could we simplify to make it prettier? Sure, but we should be able to make it match with that. Got it? Perfect. That's exactly what a multiple choice answer would have had. They cannot come in because this is to the 9th power. I can't go take in just a 40x and be like, hey, by the way, you can be to the 9th too. No. 40x to the 9th power can mess up all sorts of stuff. So it would just be 40x parenthesis 2x squared plus 1 to the 9th. What are we speeding up right now? Just use to powers. That's it. That's all we're speeding up. Just use to powers. But can we speed up other Oh, we can speed them all up! Instead of sine of x, sine of u. Instead of cosine of x, cosine of u. Instead of tangent of x, tangent of u. Instead of cosecant of x, cosecant of u. Instead of secant of u. Look, it's the exact same thing. But what's at the end of every single derivative rule? U prime. That was a little high. U prime. That's better. But what do you see that's inside each of these trig functions? The u's have to be in there. We can't go messing things up, yeah? Keep the inside unchanged. But just because we're learning chain rule, does that mean that the problems will only have chain rule? Isn't this guy a product first? But what's in the product? A chain that I could use the tangent of u for. So as we finish up today, our final example will be like, oh yeah, this is just in context of all the rules I already know. So I would... But when I go to d second, how would I take the derivative of tangent of u? Secant squared of who? Of u, which is? Times u prime. And my final answer would be, well, I guess I could pull out an x. My final answer would be x2 tangent of 5x plus 5x secant squared of 5x. Dun, 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 dun. Go play with homework and you really, really, really want to get started tonight. Bye. Chain rule. Derivative of the outside. Keep the inside unchanged. Times derivative of the inside. U prime. Don't kill bunnies, and I'll see you later.